It was an ordinary prehistoric day 66 million years ago. Megafauna was having megaflora for brunch. Nobody had the faintest idea that a catastrophe was going to strike in
3, 2, 1.
A space object whose diameter equaled half of Manhattan hit Earth. According to scientists, this event could have triggered a mass extinction. As a result of climate change, around 75% of all flora and fauna died. Almost all dinosaurs were gone, except for the first pioneers of the sky. But why would scientists think that the culprit of the tragedy was from outer space? Who was the suspect here on Earth? What were the investigative leads? How was the evidence gathered? And was there an asteroid in the first place? What could lower the boom on these animals if they were the size of trucks? Over the past 200 years, there have been a lot of theories, from scientific to ridiculous. In the early 20th century, some paleontologists thought that if anyone had to be found guilty of killing dinosaurs, that it had to be dinosaurs. Here's the scoop. Giants grew higher and larger by inertia. Eventually, the size race took all their strength and led to self-destruction. Sounds hard to believe. In the meantime, paleontologist George Wieland thought that the reason why dinosaurs had gone extinct had been other reptiles that lived nearby. He assumed that dinosaur eggs were a favorite meal of snakes, monitor lizards, and even dinosaurs themselves. Since everyone was on the egg diet, many babies never had a chance to be born and grow. The scientific world dismissed this theory. Physicist Wallace Tucker and paleontologist Dale Russell got the most solid lead on the killer. They said they knew who'd been behind the extinction and accused the nearest supernova. As a result of its explosion, X-rays attacked the upper atmosphere and triggered a cold wave. Researchers, however, didn't find any traces of such an explosion up in space. But instead, they found a crater that turned out to be a graveyard of all the previous theories. How could one single finding change the entire course of the investigation? How could they determine the crime scene? And what was found there? Geophysicist Glenn Penfield worked for a Mexican oil company called Pemex. In 1978, he was examining a magnetic survey map of the Gulf of Mexico and noticed a semicircular arc, a part of the Chicxulub impact crater. The crater reached 150 kilometers in diameter and was 20 kilometers deep. And that's almost 2 times deeper than the Mariana Trench. Penfield presented his findings at the Society of Exploration Geophysicists Conference, but his report attracted scant attention and was swept under the rug. Several years later, the father and son team of Louis and Walter Alvarez, a physicist and geologist, made an important discovery. In different parts of the planet, they found an abnormally high iridium-enriched layer of clay that was 66 million years old. Iridium is a rare element on Earth, but it's frequently present in space rock samples. What's more, bits of shocked quartz and tektites found in that layer also pointed towards an interstellar visitor. These bits emerged due to extreme pressure produced by a nuclear explosion or a meteor strike. Based on this evidence, the team concluded that the mass extinction was caused by a fall of a celestial body. In another 10 years, Glenn Penfield and paleontologist Alan Hildebrand examined the drill samples from the Chicxulub crater. All indications were that the giant space object had fallen in that exact location. So the researchers found the crime scene and soon even identified two suspects. Who were they? A comet or an asteroid? Let's thoroughly study the habits and abilities that each of them has. Researchers at Dartmouth College, New Hampshire, attempted to find the culprit. They suggested that the amount of iridium in the examined layer of clay was highly overestimated, and that when the explosion had occurred, much fewer fragments had gone up into the atmosphere. When scholars recalculated the amount of iridium, they claimed that it could have been brought to Earth by an asteroid 5 kilometers in diameter, and it could have originated in an asteroid belt located between Mars and Jupiter. That place, by the way, is still chock full of space boulders prone to change their trajectory at any moment. But how can we explain the size of the crater? The New Hampshire team gave their own answer: a 7-kilometer comet. Obviously, this comet came from the Oort cloud. The vast distance it had to cover on its way to Earth let it reach the speed required for a massive explosion. Avi Love and Amir Siraj, astrophysicists from Harvard, supported the charge. They carried out a geochemical analysis of the crater's rocky outcrops and stated that 100% of comets and only 10% of asteroids that cross our orbit have the chemistry matching the one found in the Chicxulub impact crater. However, most researchers absolutely hated these theories, and not only because of gross errors that both teams made in their studies. What were the facts proving all of that had been an asteroid's fault? Let's take a look. Fact number 1. According to up-to-date assessments, the fallen object brought around 250 tons of iridium. A comet 7 kilometers in diameter would have brought no more than 200 tons, as comets are composed of lighter elements and ice. Meanwhile, a 10-kilometer asteroid could be capable of handling the task. Fact number 2. The last time when a massive object fell on Earth was 250 million years ago. Comets of this kind hit Earth approximately once every 4 billion years, and the chance it ended up in the Chicxulub is less than 7%. At the same time, 10-kilometer asteroids fall every 350 million years. This gives us more than a 50% chance. Fact number 3. The structure of the impact crater consists of carbonaceous chondrites. It's a type of rock that contains water and organic compounds typically found in asteroids and comets. However, that chondrite subtype is common only for asteroids. As you see, scientists have investigated this case really well, so there isn't a shadow of a doubt that the fault lies with the asteroid. But why is that bad news for us? Of course, according to forecast, a new 10-kilometer asteroid won't disturb us for the next 284 million years. But don't forget that there still may be a 7-kilometer comet hurtling through the vastness of space, and the probability that it'll hit Earth has long been more than 7%.